Hello everyone. Today I'm going to talk about my engine, Angel Engine. Angel Engine isn't just a map editor, it's an environment where an entire online game is built. Locations and data, items, skills, quests, characters, and mobs are all presented in a single format for both the server and the client. The editor is tailored for MMORPGs and similar online projects. The world and rules are defined here, and builds for different platforms are generated from the same project without manually duplicating content. The NPC editor section stores the types of non-player characters for spawns on the map, mobs, neutrals, and any NPCs. Entries are organized into folders. The left-hand panel contains everything for the server: general settings, level, respawn, color, stats, combat with damage type and scaling, behavior, aggression, patrol or wandering, speeds, and radii. Below are skills, drops, optional NPC versus NPC, immunities, advanced combat, and AI abilities with conditions, plus a death event. On the right, animations with previews, idle, walk, run, attack, cast, death, sit, sleep. Each action has its own sprite sheet, 4 or 8 directions, frames, and speed. The collision box for hits is also there. NPC entry, a unified entity profile for client and server, not a separate image. In the game data, a fishing rod is an item in the tool slot with the fishing rod type. This flag tells the game that the item is used for fishing at marked locations on the map. For the item in the main section, you set an icon from the project's resources, the same image for the inventory and tooltips, and a folder to organize the list. The paper doll is separate for male and female characters. It's not static, but a set of animations for the equipment layer: walking, attacking, casting, etc. The client overlays them onto the player's character model, so the fishing rod is held in the hands and moves with the character. The same system applies to weapons, armor, and helmets. A single item provides both stats and appearance. Regarding performance, when changing equipment, the engine recompiles the character's atlas. The base and layers are merged into a single texture. A single atlas, instead of a bunch of layers per frame, reduces the load on the renderer, especially when there are many characters on screen. Spell Editor is a central hub for skills, damage, targets, cooldowns, projectiles, and cast animations. Both players and NPCs can access these entries. The Projectile Editor describes how a skill manifests in the game world, whether as a projectile, a beam, or an area, where the projectiles come from, what they look like, and how long they last. The template allows you to configure behavior: flying projectile, beam, area, and trajectory, standard flight, shot at a target point, homing, fan slash, spread, plus collisions, multi-hit, ricochet, ammunition, and binding to a spell. The same skill can reference different projectile profiles for different gameplay styles. Class Editor, Hero Template. At the top are the main stats: level cap, selection lock, folder, vitality, and HP/MP growth, regeneration and growth mode, static or percentage-based. Below that are base stats and per-level growth, stat allocation, experience curve, combat block, damage, crits, scaling, attack speed, animation, followed by the starting spawn location on the map with coordinates and direction. At the end of the form are spells with their acquisition levels and starting inventory. On the right are appearance options, several presets with gender and a full set of character animations, so that a single class can have different dolls without separate entries. Resource Editor. Everything on the map that can be mined or used as an interaction point: trees, ore, bushes, etc. You can set the sprite for the live state, and after mining, the number of hits, respawn settings, the required tool: axe, pickaxe, shovel, fishing rod, or none, passability before and after, and a tooltip above the object. There is a collider for collisions and clicks, a drop table with probabilities, an optional event upon harvesting, and text if no tool is equipped. Fishing Spot mode turns the resource into a fishing zone. Radius in tiles, bite wait time, rhythm minigame parameters, and fish pool: which items are caught, rarity, weights in the table, difficulty, and experience. The Quest Editor compiles a quest from stage descriptions, proposal, pending acceptance, in progress, completed, repeat and cancel flags, a list of tasks, such as collecting items or defeating NPCs, along with quantities and log text, and a reward chain, item or experience. Additionally, you can configure the visibility of quests in the log by stage, set grouping categories, and sort the list. The animation editor in the database consists of reusable clips that are later selected for skills, projectiles, item usage, etc. Each resource has 2 layers. The bottom layer is rendered beneath entities, and the top layer is rendered above the background. Layers can be copied and swapped. For each layer, you set a sprite from the animation folder, frame grid division, frame duration, number of repeats, line through mode with optional rendering, Z order, and options like disabling rotation. There's a preview with fast forward and spotlights per frame for flashes and local lighting. The recording can have audio during playback and an option to play the audio to the end. The Variables section stores named states for quests, dialogues, and events, not in the general item table, but in a separate list that is synchronized with the server. Each entry specifies a scope, player, server, global, guild, or user account, and a data type, Boolean, integer, float, or string. There is a text ID for substitution into texts via codes. The list can be organized into folders. The initial value in the editor is set for server variables. The remaining fields receive values upon character creation, guild creation, or first login, as indicated in the interface. Map mode is a separate tab featuring a canvas and a tileset palette. Drawing occurs on the active tile layer. Everything placed on the grid is stored on a per-cell basis, and then rendered in the client in the same way. The dropper tool, hotkey 1, reads the tile from the currently selected layer in the cell under the cursor. The same tile set and block coordinates on the sheet are entered into the palette. It's convenient to copy graphics already laid out on the map without having to manually select a piece. The only important thing is not to pick the wrong layer. The dropper doesn't penetrate all layers at once, but reads only the active one. Map layers aren't fixed to a specific number. You can add new tile layers, name them, place them into groups, lower, ground, water, middle, and upper, objects above the player, and change their order, transparency, and visibility. Each layer has its own grid of tiles of a single map size. A typical pipeline is terrain on the bottom layer, with scenery and traversability above in separate layers, so as not to mix everything into a single layer. A tile's data includes not only an image from the tile set, but also an auto tile mode. The auto tile, normal mode, automatically selects corners and transitions from a 2x3 set on the sheet based on adjacent cells. No need to manually set each bevel. Animated mode uses the same tiling principle but with cyclic frame animation. The preview editor uses ping-pong between frames. The speed is set at the project level, auto tile animation, milliseconds between steps. Waterfall, a separate type of auto tile with its own 3-frame loop and a separate timer in the preview. The waterfall speed is configured for it in the project. This way, water on the map can look different from a regular animated surface. Additionally, the list includes a wall mode, a 2x2 auto tile for corner joints, and a standard normal tile without auto logic. When auto tile is enabled, the brush typically places one logical block per click. Without it, you can paint multiple tiles in a tile set at once using a rectangular selection from the palette. In the preview interface, you can enable tile animation on the map to immediately see flowing water and waterfalls without launching the client. Each map in the project has a position on the world grid, grid X, grid Y. The client combines them into a single large plane. The pixel offset is calculated so that adjacent maps on the grid align edge to edge, without gaps or a second screen. At runtime, the visible area is assembled from the current map and adjacent loaded sections. When crossing an edge, the logic for switching local maps kicks in. But for the camera and graphics, this is a continuation of the same world. If the tile size and rendering at the seam match, the line between map files is invisible. For development, this division into chunks, separate maps in the editor with their own set of layers and attributes, is convenient. And for the player, it creates the sensation of a single open space that can be traversed without teleporting between rooms. A map doesn't have to consist solely of tiles. You can add a parallax layer, a PNG image. Specify a file from the resources, the offset, the parallax coefficient if desired, and the repeat along the axes. This allows you to place a single image on the location, such as a city background or backdrop, without being tied to the tile grid. If this is just a decorative image in the bottom layer group, it has no collision. The character passes freely through the image until collision logic is specifically defined. To make the graphics stop movement, you need a block collision layer. An image from the layer set is placed there, and passability is built from the color mask. The classic red is impassable, transparent/white is passable, plus water zones or blocks for the player only/NPCs only. The server and client use this pixel map, not the alpha channel of the art itself. A separate issue is roofs and the upper parts of buildings. Collision is often cut along the walls at the bottom of the image. But if the same PNG is used only as the bottom layer, the player won't visually end up behind the pediment. To add depth, another PNG layer is added to the top group above the entities. You can use a semi-transparent facade overlay or just the top elements. The character ends up under this layer, the image slightly overlaps them, and the scene looks more three-dimensional, without a jagged tile grid covering the entire building. If necessary, there is a hybrid type, a combination of a background image and tiles on top of it in a single layer. In addition to tiles and images, the map contains an attributes layer, a logical grid that isn't visible to the player as a separate texture, but which the simulation reads. A brief overview of the types: passable and blocked, warp, Z-level, item spawn, resource spawn, sound in area, cell animation, sliding, hook point, path blocking for NPCs, creatures, and light sources. For trees and any ground-based resources, use resource spawn. The cell contains an entry from the resource database: sprite, alive/dead, tool, drop, respawn. Several such markers in a row create a grove, or a strip of identical objects, without having to manually place each instance on the map as a separate object. In the game, the resource checks which tool is equipped. For wood, it's an axe. As long as the object's life hasn't been depleted, the sprite of a living tree is displayed. After the final harvest hits, the client and server switch the object to the post-felling sprite. That is, visually a stump or other dead graphic from the resource record remains. The drop table for that resource specifies which items are given to the player, for example, logs, along with their quantity and drop chance. After the respawn timer, a full-grown tree may grow back in the same spot if configured that way in the database. You can assign the same resource spawn attribute to a river or any tile, but the database entry must be marked with the fishing spot flag. The editor automatically sets the tool type to fishing rod, and in the fishing block, you set the zone radius in tiles, the bite wait time, the rhythm minigame parameters, and the fish pool, which items are caught, their rarity, weights, and difficulty. In-game, the server checks that the player is within the radius, has a valid session, and that the point is marked as is fishing spot. Then the sequence proceeds. Cast to wait for a bite, to minigame based on hits. If successful, the fish selected from the pool, or another item from the catch table, is added to the inventory. Without a fishing rod equipped, the interaction does not start. This is a separate scenario from the usual hitting mechanic. The attributes layer includes an animation type. For a cell, you select an entry from the animation database, a 2-layer clip from the editor. Optionally, you can enable the block flag if this effect is to participate in collisions, rather than just being rendered. On the client, this tag plays the same animation content specified in the resource, useful for campfires, fountains, traps, or any looping scenery without a separate NPC or tile, simply to demonstrate that the attribute to runtime pipeline is active. A separate map layer mode, NPC, spawns. A link to an entry from the NPC database is attached to each cell, complete with stats, behavior, and a list of skills. A single spawn point at a location is sufficient for an enemy to appear with the correct profile. If the entry has aggressive behavior and the player enters the line of sight, the server puts the mob into combat and begins to process its attacks and abilities according to the same rules as for the player. Hits and damage are calculated on the server. The hero responds with skills from the spellbook. For each, a cost, target, projectile, or area is set, along with cast and hit animations from the animation library and an equipment clip. The client merely plays back what the combat state has already determined. When an NPC's HP drops to 0, death and loot are triggered. After respawning via a timer, the spawn point can generate a new instance again. There may be a second spawn point nearby on the map with a different template from the database. If this NPC has NPC versus NPC mode enabled, and the aggro list contains the required IDs of other NPCs, the server considers them mutual targets within line of sight. They can fight each other while remaining hostile to the player according to their aggression settings. An AoE attack that hits both adds damage to the threat table. NPCs mark the player as the source of the damage and, when threat is high, switch their priority to the player before targeting an enemy mob. Visually, this looks like redirecting aggro from the entire group with a single spell, though internally it's a standard combat calculation and target selection based on threat and distance. In the event editor, a script page is built from commands, displaying text with an optional character face or sprite, followed by a conditional branch, based on a variable, quest, status, etc. The condition has separate lists of commands for the yes and no branches. The response options command is used to select the player's response. Each line creates its own subchain of commands. A typical example is accept/decline. The start quest command retrieves an entry from the quest database. For example, a quest with the objective kill n NPCs of a specific type. After acceptance, the log pulls the wording from the description into the process, and progress proceeds automatically. Each kill of the required goblin reduces the counter until the task is completed. without a separate script for each corpse. The event is placed on the map as an event object with a trigger based on an action or entering a zone. After that, the chain of commands is executed by the server, just like in single-player RPGs with a visual page editor. The editor menu, Angel Engine, includes an option like Build Game. This runs a general build script for the target platform, server, PC, web, or Android. You select the project. The resulting files are saved in the builds/folder next to the project, a separate directory for each platform. Server, a node build for hosting the world. PC, a client as a desktop application. Web, a static client for distribution via HTTP and playing in a browser. Android, a mobile package of the same client for the general server address. A single running server accepts connections from different clients simultaneously. If you launch 2 desktop clients and 2 browser tabs on the same world, each screen displays the other connected players. Positions and animations are synchronized with the central simulation. These are not 4 separate instances. There's still a lot more going on under the hood in Angel Engine: crafting, a UI builder, guilds, a command network, and more. But we can't fit it all into a single video. We can cover what didn't make it into this video next time. Angel Engine is currently in active development. The editor's features and interface are being refined over time and may differ from the screenshots that will appear in future versions.